The next session is important because it's a life-changing skill, the ability to solve problems. Cultivating problem-solving skills is crucial in one's success, in the professional as well as in the personal, if you ask me. This illuminating session will elucidate the psychological processes that help you spot, analyze, and solve the problems. It will also walk you through the methods that can help you to cultivate better problem-solving skills. To help us gain more clarity on the subject, I welcome Mr. Anand Mallya, founder of Quantech Origin. He will be talking on the topic of the psychology of problem solving. Mr. Ananth, please join me.
A very good morning to everybody. I know we've had continuous sessions from morning. And the announcement of the session that I'm going to handle is completely to do with math. So I already can actually understand the pulse of the audience that you are not open for problem solving. Now, I just wanted to begin with a basic question. How many of you in this entire session here actually fundamentally love math? Let's make it two-way. This is going to help me because otherwise this entire session will be way above the head. How many of you love math? Okay, how many of you do not like the concept of problem solving itself? Do not like mathematics at all? I have people raising both hands and legs. Okay. Just wanted to understand, we began our journey in 2009 in India, where we analyzed that people were having a lot of potential in order to make it into the corporate industry, but fell short because their problem-solving skills was not matching what the corporates were actually looking like. And then what we did was, we started understanding the entire patterns of the industry across various verticals, and then started preparing content very specific to some of the industries. Before that, I just wanted to understand, everybody have your pen and papers with you. I'll just put a problem statement, and I'll make this very interactive because only then my entire session will be very useful to the audience. I'll begin with one problem. I want everybody to analyze what you understood about the problem statement and then come up with various answers. And then I will show you how to do boundary value analysis. By boundary value analysis, I mean by worst case, what will be the scenario for the entire case, and by best case, what will be the answer for the entire case. Okay, so are we good to start? Okay, I'll put something very interesting. I'll move across the audience so that we have this entire session very interactive. Now, I'll put the first problem for all of you. We have a king. Okay, this king ordered 100 crates of beer. I'll just give a problem statement for everybody. I just want everybody to interact. We have a king. This king ordered 100 crates of beer. Now, what's interesting is, one of the king's enemies will sit down and poison one complete crate. One of the king's enemies will sit down and poison one complete crate. Now, we don't know which one. So the king is going to line up 10 prisoners for an experiment. The problem statement here is, since we don't know which crate is poisoned, once the prisoners have actually tasted the poison, it will take them 10 hours to die. It will take them 10 hours to die. And precisely 10 hours from now, the king also has a party. So you have to tell me logically how many crates of beer could be safely used for the party. First, let me get the data again for everybody, for people who are trying to make notes and trying to interact with me. So how many crates of beer did the king order? 100. Everybody's got that? So how many of them were poisoned? Exactly one. How many were poisoned? One of them. So how many prisoners you have for the experiment? 10. How much time does the prisoner take to die once he has tasted the poison? 10 hours. And after 10 hours, what do you have? You have a party, which means I don't have time. So you have to tell me, worst case, how many crates of beer can be safely used for the party? None. Can I have an answer? Can I have a few people giving me answers? Yes, please. Thank you. Possibly 90.
90, yeah.
Yeah. Can you please tell me how did you arrive at the answer, sir?
So I'm going to take randomly the.
Can you use the mic because this is. Yes, sir.
So there are 100 crates of beer.
Yes, sir.
One is poison.
Yes,
I
sir.
don't know which one.
Yes,
I
sir.
choose randomly 10 crates.
Correct.
Give it among 10 people.
Okay.
Worst case, that's the best case situation.
Correct.
That we find one of the prisoners dying. So basically, we are left with 9, which is not poison, and 90 are not touched. So that makes it 99, which can be safely used, because 1% probability is 1 out of 100, which is poisoned. That's a best case.
Okay. See, just to put it to the audience in layman terms, see, now we have 100 crates of beer to be tested. And we have 10 prisoners who are going to actually consume these crates. Now, the worst case, I will actually be able to use 90 crates of beer. I'll tell you how. I will just call the prisoner number 1 and ask him to taste crate number 1 to crate number 10. 1 drop each. Let's not get emotional about how much beer is getting wasted. Prisoner number 2, 11 to 20. Prisoner number 3, 21 to 30. So on, prisoner number 10 will taste 91 to 100. Now, there will be a scenario where one of them will die. So I don't know which of the 10 caused the death, but I'm extremely sure that the rest 90 crates are safe for the party. Everybody agrees? Am I in sync with the audience? Okay. See, I am not going to keep this session completely through algebra, but I'll try to keep it as interesting as possible. Fundamentally, among all the educational leaders out here, I belong to somebody who talks math. So I'll try my best to keep this very interactive. Okay. Can anybody else come up with a better scenario where I can save more than 90 crates of beer? No, let's not get emotional about who poisoned the beer, whether I'm going to find him, whether the crates are open, whether the... We're not getting into any of that. I want you to logically reason.
No, can we apply the prisoner's dilemma here?
Sorry?
Can we apply the prisoner's dilemma here?
You can apply the prisoners?
Can we apply the prisoner's dilemma scenario here? That the prisoners have, you understand, right? The prisoners are poisoned, but nobody will tell who has poisoned. And we can, you understand?
No, sir, no, sir, no. No, because I'll have to use the beer for the party. At the end of the day, after 10 hours, you have to tell me which of them is poison. So let's take a scenario for everybody here. Suppose I had 10 hours and 10 minutes for the party to begin. Suppose I had 10 hours and 10 minutes for the party to begin. It would have solved the problem because I'd have given the first crate to the first prisoner right away, given 1 minute gap, given him the second crate, given 1 minute gap, timed it with the third crate, and so on. So what's going to happen? Exactly after 10 hours, if the first crate is poisoned, the first one dies. After 1 minute, the second one dies. But I don't have time. Basically, what I have done is I made it completely time bound. So, can anybody tell me how do I use more than 90 crates of beer? Everybody is thinking about the beer or the problem? Anybody else wants to come up with some answers? Basically, then I will tell you how this entire thing can be mapped and why these kind of problem solving skills are very important for students passing out of UG or PG courses across the globe. Anybody else? Yes, sir. You're giving me more reasons not to love math, my God.
Yes. Maybe it's possible to mix the beer. I'm here.
Okay, yeah, please tell me.
Yes. Maybe it's possible that we can mix
but
beer.
in what proportion will you mix and how will you come to the answer?
Oh, then we need maths, and I'm not so good at maths.
I'm not, let's keep it very interesting. I'm not expecting you to mix it through math. Okay, let me give one piece of information. We all understand that somebody's ability to convert whatever he has in his imagination to words was called arithmetic in school. And somebody's perception converted into variables was called algebra. And somebody who can really convert his imagination into diagrams was called geometry. And somebody who can fundamentally play with words, variables, or diagrams has actually mastered math. We agree? Okay, but math is way beyond just words, variables and diagrams. Math is also to logically think on how we can build different scenarios. Okay, I'll give you a scenario now. Yes, please, sir.
As an ethicist, I would have another approach. You know, you have a logic with mathematics. That's fine. I would ask, how can we have a scenario where we have nobody dying? So we ask that nobody is eating. Huh? So nobody will die. So the logic of ethics may be different from the logic of mathematics. Both are logical. It's a logic, but so I would enter through another door than the mathematical logic.
Yes, sir. But how do we actually fundamentally get into which crate is poisoned? Okay, I'll give everybody a scenario now. Okay, you want to answer this? Please.
We can find out the one that's missing, but they won't be ready to be used for the party though.
Correct, but how do you do that?
Okay, so the person who dies, we have his 10, the 10
The 10 of
crates.
them, yeah, but which
so
among them again?
We'll have the prisoners try them again.
You'll have the other 9 of them try them again,
And
but
then
they will
10
die
hours.
after 10 more hours and party is long
we'll
over.
keep doing that till we get the one that's missing.
I wish we had so much of time. Now, I'll just give the audience a scenario to think. See, I'll just tell you, the best thing about math is there is no particular solution. I can think of a problem in n number of ways. I'll just give everybody a scenario. What I'll do is like a kid, I'll fundamentally go to all the 100 crates and label them as 1, 2, 3, 4, 5, 6, etc. till 100. I didn't do anything complicated. I labeled all the crates like a kid. I will call the prisoner number 1 and tell him, go and taste from all the crates which have the digit 1 inscribed on the crate. So prisoner number 1 will drink from crate number 1, crate number 11, 12, 13, 14, 15, 16, 17, 18, 19, 21, 31, 41, 51, 61, 71, 81, 91 and crate number 100, because fundamentally all these crates had 1 inscribed on the crate. Till here am I making sense? So what will prisoner number 2 drink from? 2, 12, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 32, 42, 52, 62, 72, 82, 92, correct? What will prisoner number 3 drink from? 3, 13, 23, 30, 31, 32, 33, 34, 35, 36, 37, 38, 39, 43, 53, 63, 73, 83, 93. Agree? What will prisoner number 9 drink from? 9, 29, 39, 41, 42, 89, 99, 99, 99. Correct? I will call the prisoner number 10 and tell him, please go taste from all the crates which have 0 inscribed on the crate. So prisoner number 10 will fundamentally drink 10, 20, 30, 40, 50, 60, 70, 80, 90, 100. I'll just give you a small inference. Crate number 11, it is written 1, 1. So it was drunk only by the first prisoner. Crate number 12, it is written 1, 2. It was drunk by the first prisoner and the second prisoner. Crate number 13, it is written 1, 3. It was drunk by the first prisoner and the third prisoner. Crate number 19 is written 1, 9. This was drunk by the first prisoner and the 9th prisoner. Crate number 25, second prisoner and the 5th prisoner, etc. till 100. Everybody agrees? Now, precisely after 10 hours, I found prisoner number 3 and prisoner number 7 are dead. Now, fundamentally, either crate number 37 is poisoned or crate number 73 is poisoned, but the rest 98 crates of beer are absolutely safe for the party. Agree? Exactly after 10 hours, suppose I found prisoner number 4 and prisoner number 6 are dead. Either the crate number 46 is poisoned or crate number 64 is poisoned, but the rest 98 crates of beer are absolutely safe for the party. Or exactly after 10 hours, I found only prisoner number 7 is dead. Either crate number 7 is poisoned or 77 is poisoned, but the rest 98 crates of beer are absolutely safe for the party. Agree? Now, there's a good news. The good news was I was able to save 98 crates of beer. But the bad news is, this was not the answer. This was not the answer. This was just to get to 98:2. Anyway, I will keep this short. I'll have more people interacting with me in the break in case you want to find out 99:1. Shall I give you one more situation now? I'll keep it without numbers. Shall we try? I'll try to keep this without numbers. Now, fundamentally in math, we've also heard of something called binary logic. Something called the truth table. Everybody's written T, L, for a lot of scenarios. And this has helped even business people write a lot of test cases. I'll just give you a small case. I want this to be very interactive again, otherwise the essence will be lost. Now let's imagine 5 girls meet for a party. I find all the men are interested now. Okay? Now, 5 girls meet for a party. And if girls meet for a party, what do? Gossip. Yeah. Now, the first girl gets up and she addresses the group and she says, among the 5 of us, exactly one of us is lying. Lying as in not speaking the truth. The second girl gets up and says, no, among the 5 of us, exactly 2 of us are lying. The third girl gets up and says, exactly 3 of us are lying. I'm giving you a very simple question this time. The fourth girl gets up and says, exactly 4 of us are lying. And the fifth girl gets up and says, all 5 of us are lying. Now the question is, which girl is speaking the truth and which girl is lying and why? I hope the question is very clear. There are 5 girls who met for a party and they started gossiping. The first girl gets up and says, exactly 1 of us is lying. The second girl gets up and says, exactly 2 of us are lying. The third girl gets up and says, exactly 3 of us are lying. The fourth girl gets up and says, exactly 4 of us are lying. The fifth girl says, all 5 of us are lying. The question is, which girl speaks the truth and which girl lies and why?
All 5. All. No. First one knows she is lying.
First one knows she's lying, but why?
Because she is saying one of us is lying. She will know best about herself. Second one says both. So
Sir,
she takes herself and the other.
It's a request. Please keep the answers without emotional quotient. I want this to test somebody's logical ability and not emotional quotient. It's a very interesting answer. Can anybody else participate? I have a promise that I will not ask you one-on-one algebraic expressions after that. Okay, let's backtrack. Since I am given only 30 minutes, I will not even exceed time. Let's backtrack, okay? Everybody has understood that a child will actually solve a problem top down or bottom up. Everybody fundamentally understands problem solving is of 2 varieties. I can go top down or I can go bottom up. Agree? Now let's understand, when there are 5 girls and they made 5 different statements, what does this even mean? When there are 5 girls and they have made 5 different statements, what does this even mean? It means either all 5 of them are lying, or it can mean 4 of them are lying and any one of them is speaking the truth, because they are basically disagreeing with each other. Agree? It can fundamentally mean only 2 things. Either all 5 girls are lying, or it can mean 4 girls are lying and one of them is speaking the truth. Can I say, after 5 of them made 5 different statements, can I say 3 of them are lying and 2 of them are speaking the truth? Not possible, because they are not agreeing with each other. Agree? Now let's take a situation now. I'll backtrack. Let us take a case where the first one is speaking the truth. If the first girl is speaking the truth, she said exactly one of us lie. And if that is the truth, exactly one of them must lie. And if exactly one of them must lie, how many must speak the truth? 4. Can 4 girls here be speaking the truth? No. That is why the first girl is lying. Let us take a situation where the second girl is speaking the truth. She said exactly 2 of us lie. If that is the truth, only 2 of them must lie. And if only 2 of them lie, how many must speak the truth? 3. Can 3 people here be speaking the truth? No. Hence the second girl is lying. If the third girl is speaking the truth, she says exactly 3 of us lie. If that is the truth, only 3 of them must lie, which means 2 of them must be speaking the truth. Is that possible? No. So even the third girl is lying. If the fourth girl is speaking the truth, she said exactly 4 of us lie. Which means, how many must speak the truth? 1. Is this possible? Yes. This is possible. I'm not telling this is the answer, but this is possible. I'll come to you, sir. Let us take the situation of the 5th girl to be speaking the truth. First of all, the 5th girl cannot be speaking the truth. She said, all 5 of us are lying, which means it includes herself. So the 5th girl can never be speaking the truth. So hence the solution for this is, logically, the 4th girl is speaking the truth and the other 4 girls are lying. Now if you backtrack, the entire question is coming into the answer. Am I making sense? Okay, quick, last, I'll take just a couple of minutes and I'm done. And this couple of minutes will be on the fundamental of math. And this will be on addition, subtraction, multiplication and division. Now as soon as I said division, everybody is sleeping already. Let's hope that some of you can get your addition and subtraction at least properly. With that, can I put in a question? Okay, let's go scenario based so that you give me an answer. So you still hate math? Okay, today is what day of the week? Today is what day of the week? It's Tuesday. Everybody is with me? Okay, what day of the week will it be after 6 days from today? Count slowly like a kid.
Tuesday.
From Tuesday, 6 days later is? Wednesday, Thursday, Friday, Saturday, Sunday, and Monday. Agree? Everybody's with me? Let's count like a kid. It's Monday, right? Okay, what is it fundamentally 20 days from today? Which day of the week is it after 20 days from today? Again, Monday. How did you compute this? Yeah, 6 plus 2 weeks. Brilliant. Okay, everybody's with me as long as it is in addition limits, right? What is it after 50 days from today? 50. 50 days from today. Everybody knows 7 tables of 7. 7, 14, 21, 28, 35, 42, 49, 56, 63 and 70. Everybody knows this? Everybody knows this? Otherwise I will not be able to give the solution at all. Everybody knows this? Okay, let me summarize. 7, 14, 21, 28, 35, 42, 49, 56, 63, 70. Everybody knows this? Yeah. So how do you compute 50? Your brain will tell it is 49 plus 1. Agree? Yeah. Your brain has already told you after 49 days it's Tuesday. Yeah. And your brain has told you plus 1, make it Wednesday. Everybody agrees? Now I have a question. What day of the week will it be after 50,000 days from today? Everybody is asking me when is the lunch break? Answer is Monday. Done? Understood? Okay, I'll just put a scenario now. I will just summarize what I saw in thin air and then I'll summarize how do you get to the answer so that you have something to take away today and enjoy the session of math at least on your own. So let me summarize. I have 7, 14, 21, 28, 35, 42, 49, 56, 63, 70. Visible? It's my private cloud. Visible? Let's do some cloud computing. Now 50,000 is in my brain. Fundamentally 7 times 49. I don't need 49,000 days. It is back to Tuesday. Everybody's with me? I'm left with 1,000 in my brain. It is the same Tuesday after 700 days. I'm left with 300 in my brain. 7 4 times 28. It is Tuesday after the next 280 days. I'm left with 20 in my brain. 7 2 times 14. I'm left with 6. 6 days from today it is Wednesday, Thursday, Friday, Saturday, Sunday, Monday. This is slow motion replay. I'll tell you how your brain must actually think. If it is Tuesday today, what happens after 100,000 days? So brain will tell, remove 70,000, 30,000, remove 28,000, 2,000, remove 1,400, 600, remove 560, 40, remove 35, 5. 5 days from today it is going to be Sunday.
Mr. Ananth, you lost us at Wednesday. I'm sorry, I have to interrupt you. You have 30 seconds.
I'm done. So I'll just take the last 60 seconds of your time. So everybody imagine that 100,000 in your brain. Fundamentally, I don't need 70,000 because it was back to Tuesday. I was left with 30,000 in my brain. 7 4 times 28. So I don't need another 28,000 days because it is back to Tuesday. I've left with 2,000 in my brain. 7 2 times 14. So I didn't need another 1,400 days because it is back to Tuesday. I was left with 600 in my brain. 7 8 times 56. I didn't need another 560 days because it is back to Tuesday. I'm left with 40 in my brain. Now your brain will tell 7 5s are 35. 5 is left and you'll compute it as Sunday. Anyway, I'm thanking GFEL for giving me an opportunity to come down from Bangalore and give my insights into problem solving. Of course, I was also going to tell you what is the analysis behind every thoughts that you put, but I didn't have so much of time. I hope you enjoyed the session. Thank you, GFEL.
Thank you very much, Mr. Anand.